Let us start our class today by going by with steam drum. You know, why the discussion of the movement of fluid like vapor, water, and air vapor water mixture in the boiler system, we have gone through the downcomers and risers, the pipes like downcomers and risers, from which collects the stream from a drum and send it where downcomer collects the steam from the drum and send it to the riser. Riser is placed inside the furnace of the boiler itself, where it acquired heat, and the water which is being supplied by the downcomer, it in the riser converted to heat, not in a full extent, almost say 80 to 70, 80 to 85% extent. And this dicomer, this fluid mixture of saturated water and moisture goes back to the dicomer and goes back to the drum itself, and it is then sent to the superheater, to which is in that they are the next stage. Now, the risers, let us go through what we are some points about the steam drum itself, which is mainly the collector of water, water saturated water and steam, and also the send, also the sender of the sender of stream to the next unit like superheater itself, air superheater itself. Now, what does this steam drum functions like this? It rises a discharge into the steam drum, a mixture of water, steam, and foam and sludge. What is the going on here? What they told that riser is done first of all send water, say, which is saturated with steam, then steam, and along with it foam and sludge. Means there are a lot of impurities exist in the water, which creates the different slag, which creates different slag, a good amount of slag itself, which is being transmitted through the flow of water from uh, from the downcomer riser and to the drum itself, of the steam drum itself. This strain must be separated from the drum before it leaves the drum, so that drum cannot supply moisture or steam filled with certain stages like this. So the most important part is to all these strains must be separated from the drum before it leaves this drum itself. Now, any moisture carried with drum steam to the superheated tubes contains dissolved salts. Actually, the water which is being used throughout this boiler system is not fully purified. It is normal river water or sometimes ponds water like this, mostly the river water itself. And it is mostly, although they are same water is being recirculated again and again inside the system, there are the points, moments or instants where you have to draw the fresh water from your source, like say from the river itself. Now, any moisture carried with the steam uh, should have in the steam to the superheated tube should have dissolved salts. So there are a lot of impurities present in the water, which one of the most important impurities is the dissolved salts of different types. If the superheated evaporates and the salts remains deposited in the inside the surface of the tube to form a scale which is difficult to remove. Problem is here, superheater is only supposed to get the steam only at around 100 degrees centigrade, and which is heated to around superheat around 500, 560, around 600 degrees centigrade or so. But with this temperature rise, any salt cannot be heated. Any salt cannot be converted. It remains as solid as ever. And if you can remove it before the going into the superheater, it will it will just uh, it will just deposit there and create a coating over the surface of the superheater itself. Now, coating or scale. over the surface of the superheater, over the tubes of the superheater itself. But superheater is by construction, it is a spiral shaped tube is inside it, which is much difficult to remove by normal ordinary cleaning, also not stopping the total boiler system, etc. So, in order to avoid these difficulties, the scale is supposed to be removed. The scale is supposed to be removed, uh, removed. Uh, this scale is always reduces the rate of heat transfer itself, ultimately the leading to failure of the superheater tubes by overheating and rupture itself. The problem is superheater is being heated by the flue gases, and if the heat is not directly supplied to the water itself, it is being absorbed by the walls of the tubes or by the slags or the salt deposit on the type of the tube. What will problem will that wall of the tube will get heated and heated along with the salt itself, and ultimately what will do, it will create crack or pierce the pierce the walls of the superheater, and thus rupture the walls of the superheater, and it is overheating, and as a result, it will not function again, and you have to replace things. Superheated tubes are generally exposed to the highest steam pressure and highest temperature inside, and the maximum gas temperature on the outside itself. So superheater is the final supplier of heat, supplier of moisture, which is under highest pressure and which is under highest temperature, and its surroundings is given the highest amount of heated gas from the furnace itself. So the superheated are exposed both, and the maximum gas temperature are on outside. They are made supposed to be made with the costliest heat uh, heat transferring costliest heat transferred medium. So ultimate care is to be taken so that no damage is done to it by the excessive carryover of moisture with the steam. So the what is the problem with the drum itself? Drum is the supplier of steam to the supervisor heater, and it is also the supply of saturated water to the downcomer, and from downcomer to the riser. Riser is placed inside the furnace itself, and furnace heats this saturated water coming inside the riser, and it is converted into the steam and sent to the steam drum, boiler drum again, steam drum or boiler drum again, and boiler drum then supplies this steam to the superheater itself. But problem is we are using mostly the river water or some ponds water in the thermal power generating plant, where which is not totally purified, and it contains a lot of different type of salts and other impurities there. So what the supervisor is receiving from the riser, as what the steam drum is received from the riser, is first of all the saturated water and steam, as well as slags, which contains the different types of salts and certain foams, and which is also detrimental for the steel tubes, because it is different created due to the reaction of the salts with different content to high heat, and all are absorbed inside the drum itself. But drum cannot supply the moisture with any sort of scale, any sort of salt inside it, any sort of salt or other impurities inside it, because you see this superheater as a whole is increases is under high pressure and high temperature, and it increases the temperature of the steam from this boiling point, say 100 degree or 101 degree, to 560, almost 5 times more. Thus superheater is exposed in superheater itself is exposed in uh, to high pressure and temperature inside these tubes were used, because the steams are supplied to it to create to a high pressure, and it is to be heated to a highest temperature, and it is being surrounded with the highest temperature of the furnace, flue gases of highest temperature in the furnace. If if the walls are coated with these impurities, slags, or the other salts, etc., what will happen? This transfer of heat will hamper, and if inside the super water inside the steam inside the superheater will not be heated quickly, and most of the high heat of the flue gases of the in the furnace will be absorbed in the walls as well as in the films of the film coating of the superheater walls, and this will result in the failure or inefficient working of the superheater as well as evaporator, and ultimately it will make create rupture in the walls of the superheater. Superheater is thus made with costliest materials, and its wall cannot be removed. It cannot be removed easily, and it cannot be replaced easily. So we have to supply the superheater with steam without any impurity in it. Now, some of the impurities in the steam resist in the steam is the vaporized silicon, which will again which will vaporized silicon, which is vaporized. It is not creating the any coating in the supervisor wall, but superheater walls, but it goes to the during the impinging of the vapor to the turbine blade, it deposited on the turbine blade. Also, there will deposit over the turbine blade, which is not desirable at all. So no vapor bubble should flow along with the saturated water stream from drum to downcomer. So drum downcomer will go through, will supply the saturated water and no steam with it. Vapor bubble means some steam which should not go to this line at all. Just once again. One of the impurities, acha, it should not go to the so one no bubble will go through the diaphragm to the riser itself, or riser will receive only the steam itself, or the presence of the bubble or steam inside the downcomer in the inside the downcomer, it will reduce the density difference and the pressure head if natural circulation is being provided. Means the presence the water is saturated with steam without any vapor inside is supposed to be the highest density in throughout the circuit, and by means of own weight it will move down through the downcomer, goes to the riser and converted to into steam and moves up and goes back to the drum itself. But this process supposed to be, if there is no pump involved in it, this whole process will be supposed to be done by the natural circulation, which means only the weight of the concerned items, concerned fluids will take into action. And but if the downcomers are downcomers carries saturated water filled up with bubbles, its density will reduce. So it's the movement from the superheated to the from the drum to the riser will be affected itself. Now, water is to be adequately treated prior to filling it to the boiler as makeup water. Still, it has some impurities in the form of total dissolved solid. Still, it may have certain impurities in the form into the form of total dissolved solid. Problem is, it should be purified to the water before sending to the boiler fitting to a certain extent. But problem is, it is not totally demineralized or deionized water. because it will be expensive and time consuming work, it still have some impurities in the form of say total dissolved solid. Still it may have certain impurity in the form of the total TDS. That total dissolved solid. These solids are expressed in paste per million. These solids are expressed in paste per million to maintain a certain ppm in the ground cover itself. Just a second. Now, actually, still it may have some impurities in total dissolved sulfate. That solids are expressed, are supposed to be expressed in terms of parts per million, ppm, parts per million to maintain a certain ppm in the drum blow down is necessary. So the impurity is supposed to be there, and how much impurities will be there will be given by the total dissolved solid, amount of total dissolved solid TDS, and it will be given in terms of parts per million. So you have to check the quality of water timeline and again to judge this part per million ppm of the water, whether it is within the desired limit or not. Now, so you have to blow down the drum to certain ppm in the drum. You have to blow down is necessary the drum if necessary. If you had it is exceeds the certain ppm. If the steam generator is viewed as a steady flow device, continuity of mass required that the total solids entering is equal to the total solid leaving. Therefore, as a steady state of continuous breakdown. So the steam generator is generally always there should be steady flow. Total generator is as a whole. The continuous mass will require the total solids entering is equal to the total solid leaving, which means there is no deposition anywhere throughout this line of movement. So therefore, an active as a steady state, it should have continuous clear out breakdown itself. The impurities is equal to impurities out. So what is the impurities in? Sorry, omega FW. F is the fluid and W is the water itself, where omega W rate of feed water entering the drum in kgs per second. It is the feed water. FW is the feed water. It is the rate of feed water entering the drum in kg per second, and ppm part per million is the and BD rate of the blowdown necessary if required. Amount of blowdown, rate of blowdown necessary. It is the amount of ppm. You have ppm of the deposit of the salts which are supposed to be blow it out, plus 1 minus x ws into ppm, which means x is the quality of steam leaving the drum itself. So 1 minus x means the amount of vapor or steam water vapor mixture which is left in the drum itself. The ppm of the drum water depends on the pressure, and it should have from 1000 to 2000 ppm. The ppm of moisture carryover is maintained to as 1 to 3 ppm. So drum water depends on the pressure. It's goes from 1000 to 2000 ppm, but that moisture should have almost no ppm, almost 1 to 3 ppm, almost they should have nothing in it. So you have to clean it to that extent, which the moisture you are supposed to supply should have don't have any particle. The particle ppm will be maximum 1 to 3, which is almost nothing. So there should not be any impurities like it. So the WF, the WF rate of superheated feed water entering the drum. The feed water, how much you are entering the drum in kg per second, and rate of blowdown necessary is per in kg per second. What is the amount of air or some other process, some other liquid or chemical you are supposed to drain before to blow down this to make this deposit clear. WS, rate of steam flow from the drum. How much steam is this being supplied? X, quality of steam leaving the drum. Then 1 minus X is the is the quantity of steam leaving the fraction of the steam leaving the drum, and 1 minus X will be the fraction of the steam and water vapor left in the drum itself. The ppm of drum water depends on the pressure and series for 1000 to and it has a series from 1000 to 2000, but ppm of moisture will be around only 1 to 3. So the function of drum in a water tube boiler can be summarized as first like this. To store drum and steam sufficiently to meet varying load requirement, to store drum and steam sufficiently to meet varying load requirement. What do you mean by this thing? By the change in load from your distributor side, and it can change from different type of for a day, even different type of within 1 day or two, or even 1 month. This variation we have already discussed the load changing curve. According to the load changing curve, we have to supply the steam more or less significantly. So the function of the drum, which is the mostly the surplus of moisture, also store stored down and supply the steam, store down the saturated water and supply the steam accordingly to meet the varying load requirement. What you have seen, the load requirement will vary when load pressure changes, it rises, the supply of steam will increase very simply, and if it load is required less, then less amount of steam is supposed to be supplied so that turbine moves accordingly. Acha. To aid in circulation itself, but circulation should be proper and there should be consistent. So drum is in fact provide clearly to act as a reservoir so that it always can supply consistent and as per the requirement, and it can move, it can give you higher supply if it is required, it can give lower supply if it is required like this. Now the separate vapors of strain from water steam mixture discharged by the rider itself, because you see riser at the downcomer there is a saturated water, there is no steam, supposed to be no steam, and we have to avoid all bubbles, all bubbles or moisture content inside this downcomer, because this downcomer riser is mostly run through the natural movement, natural transporting movement. So it should supposed to be the riser, there should not have any, should be natural as rider, and this downcomer are should be natural transmission. So it is transmission will take place according to the mass or density of mass, or you can also most precisely density of the water, saturated water and water vaporated steam, water vapor and steam. So the content of downcomer should be as will be purely water itself, and this will supply the vapor and but when it is went to the riser itself, it cannot be provided totally vaporized into the steam itself. Whatever be the height, the surrounding temperature riser is there, but riser is not a very long item, long tubes, and it cannot transfer as the fluid is moving at a certain speed. It cannot transfer, have the time to transfer the full liquid water into steam itself. It returns to the drum itself with partly, mostly steam, but partly saturated water is also present, and that saturated water will recycle again and again. Now, now it is one other. So circulation, throughout the circulation, the steam drum provides an important part by keeping the quality of the mixture of steam and water itself. Now, to aid in circulation, that's it is that they're supposed to aid in circulation itself. To separate vapor of steam from water steam mixture discharged by the riser itself. You see, this is the important part of a Boiler drum is to separate riser, separate vapor and saturated water inside it. Well, because riser is supplied a mixture of saturated water and as well as vapor around 100 degrees centigrade. Then here the water portion should be kept inside the drum itself, and steam portion will send to the heater, preheated itself to the superheater itself. Now, to provide enough surface area for liquid vapor disengagement. So liquid vapor or saturated liquid water and vapor should be separated from each other, should have enough surface area and enough time is to be given to said to be changes. I mean, to be segregated separately to maintain certain desired ppm in the drum by phosphate injection and blowdown. So there is a chemical, different type of phosphates we can inject so that it can react with the drum and to make a slag which can easily blow out. So this is the to maintain a certain desired ppm, you have to make the drum in the drum itself, because incoming water may have a ppm of around 1000 to 2000 ppm, but the outgoing steam should have maximum 1 to 3 ppm, so almost nothing at all. So as a whole, what is the function of the driver? I'm just giving you a slight recapitulation of the matter. Uh, Here, now what we are saying that steam drums. Here we have steam drum. Steam drum supplies steam to the downcomer and receives the steam from the riser itself. The downcomer is a pipe which is through which saturated steam goes to the comes down and goes to the riser itself. This saturated steam should not have any air bubbles or any moisture in between it, because it will reduce the supply of steam. It will reduce the density of the water. That if the density of water reduces, its the amount of water moving per second is also reduces, because we are supposed to have the natural circulation system between the drum, downcomer, riser, and the drum itself. So heavier the liquid, it will be more quick and reasonable flow within this circuit itself. Now, problem is there, all the waters which are using in the boilers are generally not deionized properly, because it is time consuming operation and increases the cost itself. But to a certain extent, you have to purify it in order to content or reduce the moisture level of the drum itself, which is the moisture level to reduce the salt level of the drum up to a certain limit. Because say if the vapor supply to the superheater has certain deposits, certain salts inside, the salt will not superheat, and it will go on depositing inside the wall of the superheater. And what will happen? This superheater carries inside it and the steam vapor at highest temperature and at highest pressure, and it is being surrounded with flue gas at high temperature. What happens? The tubes or inside of the boilers cannot be changed easily, because it is made with costly items, and it is the circuit is like this. It's difficult to change immediately, or no short-circuit maintaining process is there. Because so you have to avoid and deposit this water inside the boiler wall, because what will happen? This deposit on the wall of the superheater will prevent the heat coming from the flue gas to the boiler water itself, because it itself gets heated, and the coating itself will get heated and absorb the heat, and it will take much more time inside the inside water to be superheated than with a clean superheater itself. So the efficiency of the more fluid fuel is required to make this same amount of heat. So efficiency will lower like this. Lower of the whole system will be lower. At the same time, these deposits go on increasing, and it is carries so much heat inside. It will ultimately have a tendency to rupture the wall and thus and rupture the wall itself. And when it is done so, its maintenance is costly and time consuming and requires stoppage of the whole plant itself. Now here you see what is going on here. This is the drum. The bubble free air would come to the down command is D and goes to the riser, which is R, and it's a mixture of saturated water and steam goes to the supervisor itself. So a portion will go to the galvanizer and a portion will be moisture will go to the superheater to for heat in superheater itself. So what we are going on here, we have to clean the water before going to the superheater and in certain other artificial means, and that will not be costly and quick, but you cannot allow the deposited salt inside the superheater itself. There's a specific amount we can allow, which is much less, almost nothing. There should not be any supervision at all. Generally, the water after which is being used in other part of the other part of the boiler itself may have 1,000 to 2,000 parts per minute uh, ppm of 1,000 to 2,000 parts per minute of deposit inside it, and that you are supposed to reduce to only 1 to 3, almost nothing parts per minute of parts per minute of parts where ppm the down pressure ppm also. No, the total dissolved content TDS, this should have a certain limit which cannot express during its full operation itself. The for steady, the impurities in fluid should be omega FW. Is the omega FW is the rate of fluid that enters the system multiplied by parts per minute of the fluid exists into is equal to rate of blowdown of the impurities plus 1 minus x omega s. Omega is the rate of steam flow, and x is the quality of steam leaving the drum itself, and 1 minus x is the uh, saturated water left within the drum itself. The ppm of water depends on the pressure and increase. Just have told you it should be within 1,000 to 2,000, and the ppm of moisture. The ppm of moisture is ppm of moisture. Everyone is mentioned supposed to be 1 to 3 only. So total function of the drum in a water tube boiler can be summarized as to store down. What will summarize to store down and steam the stored down and steam sufficiently to meet varying load requirement. So what is the function exactly of the drum is to keep a stock of steam, which can be supplied according to the requirement. Because you know that there is requirement is varying by per second, even per minute. Requirement of velocity is changing because uh, as per the certain consumption pattern of your supply may vary from time to time in different part of the day, as well as even in different moments of the day itself. So you have to control your power supply accordingly. You have to raise your supply or lower your supply as desired. So all these things is supposed to be done by the supply of moisture or supply of high superheated moisture, and you see that drum plays an important part in storing them accordingly and supply them according to need itself. Then drum should have a sufficient air in circulation, because due to natural circulation, the intermediate function of the drum is being carried out very easily. But it should have the full supplies also exist from the drum itself. Now, to separate, there's an important function is there. Drum is supply receiving from the riser the mixture of liquid water and a mixture of liquid saturated liquid water mixed and vapor mixture, which is transferred to the superheater itself. So there should be a proper and sufficient way to run to separate them, so that superheater doesn't represent any droplets of water. At the same time, it should the downcomer should not have any droplets, because it will reduce the density of the downcoming water itself. So, and enough surface area you have for liquid and vapor disengagement, we should have enough surface area. So the size of the drum is not very less. Drum will there will be specific surface area or line, where surface up to which the moisture exists and below which the steam water, saturated water exists. So enough surface area is for the liquid to vapor condensation is required. Now, a certain design ppm is done by phosphating injection and then blow down. So certain amount of heat is required to maintain a certain desired ppm in the front drum. The phosphate injection and blow down is required. So here we are not doing cleaning in any artificial way, but we are using any different type of what I will say, different type of phosphates, which will react with the salts and create a compound with the salts, which will be then blown out. This salt compound cannot be got restricted in the surface of the superheater, so you can easily blow out to clear the whole matter. Next, let us go for the modern water tube boiler itself. As per your syllabus, the all the hundreds of different accessories whose function and whose controlling equation you are supposed to know. At this chapter, you have to know what is the salient feature of the boiler itself. Now we are doing with the water tube boilers, not the flue tube boilers, where which water is being delivered through the tube and is surrounded by the hot flue gases, which is transferring heat from gas to the flue itself, gas to the water itself. This appearance of water cooled furnace valve is called water valves. Everything led to the integration of furnace, economizer, boiler, superheater, reheater, and air preheater. So furnace should be integrated. There should be integrated. The whole boiler system is supposed to be integrated with the furnace, with economizer, with boiler, superheater, reheater, and air preheater. So starting from air preheater, it will reduce to the superheater itself. And the water cooling is also necessary for superheater and economizer compartment valves and various other components, so that without the cooling of this furnace valve or this heater valve or economizer valve, if you don't do it, you will allow the heat to go out, and thus the amount of heat generated is wasted in much higher level. So the efficiency of the whole plant will be reduced. Now what happens? So a water tube boiler may have a lot of different components for superheater, economizer, um, reheater, air pressure heater, boiler itself, all these things. And water cooling also used for supervision and economizer, compartment valves and vapor reservoir valves. So is using a processor chemicals which is which is being supplied, and the water heating is also required for superheater economizer because their heat should not be wasted on the surrounding and they should be properly insulated by water cooling so that it can convert the almost 90%, 99% of its heat itself. Acha, as other screens, other components like steel, screen, dividing wall, etc. Three design consideration water is tube boilers are given in the next page figure. Type A is a boiler and natural convection calculation as in type A below. Okay, we are at the end of our time. Let's stop this discussion here. We'll finish this in tomorrow morning. Thanks for coming at least. Last class there was no attendance at all.